Welcome. In this video, we will be able to understand the concept of random variable. Also, we will discuss its two types, namely, discrete and continuous random variables. Experiments are conducted with results that are subject to chance. That is why statistical experiment is also called chance experiment. Statistical or chance experiment is any process by which several chance observations are generated. Say for example, a chance experiment of randomly selecting a female who enters a store, and buy a makeup. A random variable is a numerical variable whose value depends on the outcome of a chance experiment. A random variable associates a numerical value with each outcome of a chance experiment. A random variable is a function that associates a real number with each element in the sample space. We will use uppercase letter, say uppercase X, to denote a random variable and lowercase letter, say lowercase x, to represent a particular value that the variable might assume. A random variable is discrete if its set of possible values is a collection of isolated points along the number line. A random variable is called a discrete random variable if its set of possible outcomes is countable. For example, the number of students entering the library on a specified time. If our random variable is the number of students, then this is an example of a discrete variable. A random variable is continuous if its set of possible values includes an entire interval on the number line. This means that the value of a continuous random variable can have decimal points. For example, if we want to know the number of minutes spent by students in the library for a specified time, the result could be 10 minutes, 20 minutes. But we can also get students who spend 30.3 minutes or 41.5 minutes. The next slide will give you an example and its equivalent interpretation. We hope that this will help you understand more about random variables. In most chance experiments, an investigator focuses attention on one or more variable quantities. For example, consider a management consultant who is studying the operation of a supermarket. A chance experiment might involve randomly selecting a customer leaving the store. One interesting numerical variable might be the number of items purchased by the customer. We will denote X to this variable. The possible values of this variable are 0, 1, 2, 3, and so on. The possible values of X are isolated points on the number line. Until a customer is selected and the number of times counted, the value of X is uncertain. In this problem, our random variable is the number of items purchased by the customer. This random variable is a discrete random variable since the possible values of X are 0, 1, 2, 3, and so on. There is no possibility that the value of X is 0.5, 0.75, and so on. Another variable of potential interest, based from the previous problem, might be the time y, in minutes, spent in a checkout line. One possible value of y is 3.0 minutes and another is 4.0 minutes, but any other number between 3.0 and 4.0 is also a possibility. The possible y values form an entire interval on the number line. In this case, our random variable is the time spent in a checkout line. This random variable is a continuous random variable since there is a possibility that the customer might spend 2.25 minutes, 3.05 minutes, so on in the checkout line. Another example is taking three items from a group of electric components. If the three electric components were tested for defects, our sample space is denoted by Sn denotes non-defective and D denotes defective. One is naturally concerned with the number of defectives that occur. Thus, each point in the sample space will be assigned a numerical value of 0, 1, 2, or 3. These values are random quantities determined by the outcome of the experiment. They may be viewed as values assumed by the random variable X, the number of defective items when three electronic components are tested. If we check the values of our random variables, we can conclude that it is a discrete random variable. Let's try to solve some problems involving random variables. Get ready. Two balls are drawn in succession without replacement from an urn containing 4 red balls and 3 black balls. What are the possible outcomes and the values y of the random variable y, where y is the number of red balls? Recall that we will use an uppercase letter to denote a random variable, and lowercase letter to represent a particular value that the variable might assume. In this example, our random variable is uppercase y. The particular or specific value for the random variable is lowercase y. To solve this problem, we need to identify all possible outcomes of drawing two balls in succession from the urn. Here, we will list the outcomes using a table. The outcomes in the sample space are red then red, red then black, black then red, and black then black. Since we are concerned with the number of red balls in an outcome, therefore, the random variable y can be 0, 1, or 2. Black has 0 red ball, red has 1 red ball, same with black red, and red has 2 red balls. Let's try to solve this second problem. A stockroom clerk returns 3 safety helmets at random to 3 steel mill employees who had previously checked them. If Smith, Jones, and Brown, in that order, receive one of the 3 hats, list the sample points for the possible orders of returning the helmets, and find the value m of the random variable m that represents the number of correct matches. In this problem, we take note that the correct order of helmets should be Smith, Jones, and Brown. We will denote S for Smith's helmet, J for Jones' helmet, and B for Brown's helmet. We list all possible outcomes as shown in the table. As we observe, the first outcome in the table is when all 3 helmets are in correct order. Then, we can say that the number of correct matches is 3. In the second until fourth outcomes, only 1 helmet in correct match or position. And the fifth and last outcomes have no correct matches, therefore our lowercase m is 0. Since the correct matches can only be 3, 1, or 0. Therefore, our random variable m can be 0, 1, or 3. Why do you think there is no value that is equal to 2? In this chance experiment, we will only stop throwing a die until a 5 occurs. One possible outcome is that a 5 occurs at the first attempt, so we stop throwing the die. However, if it is not 5, then we attempt another throw. This means that the sequence of elements in the sample space is unending. It is because what if 5 will only occur on the 100th throw or more. This problem is similar to problem number 2 and 3. What do you think is the answer to the question? Get your pen and paper and solve this problem. A sample space whose number of possibilities is limited or countable is called a discrete sample space. However, if a sample space contains an infinite number of possibilities which includes all real numbers, it is called a continuous sample space. That's all for today. See you in the next discussion.